Everyone, in this video, we're going to have a look at how to find the angle between two three-dimensional lines. So in blue there, if you've got two lines, one that has a direction vector v1 and the other one that has a direction vector v2, how do we go about finding the angle in between there? And specifically, what we want to find is the acute angle. Let's just remind ourselves, back when we did our initial dot product, our scalar product of A and B, we know that the angle between those, if we have them tail to head, will be theta is equal to arc cos A dot B over magnitude A, magnitude B. That was back from earlier on. Okay, so that was the formula that we had. Now, we had to have them tail to head to force the sort of the angle between those. If we're specifically looking for the acute angle, if we want to definitely have the acute angle, how do we get the acute angle? Well, we want the answer to be in the first quadrant. That will give us an acute angle. And cos in the first quadrant is going to be positive. So what we can do to this formula is to sort of change it a little bit, just a little bit, to force the top line to be positive. If we put the modulus of that top line, that makes it positive, and the bottom line will be positive because they're all moduluses as well. And so we'll get a positive value in there, and when we take the arc cos of that, that will force a an acute angle because it will be in the first quadrant. And so that gives us our formula for angle between two vectors, which will be cos -1. Our vectors are v1 dot v2, magnitude of those over magnitude of v1 individually and magnitude of v2 individually. Okay, so that's our formula for finding the angle between two lines. Let's have just some thunder outside. It's about to to get wild, I think. So let's have a look at this example here. So there's two different lines. One is the one on the left is defined as a Cartesian equation. The one on the right is defined as a parametric. Just to sort of do a bit of revision, sort of remind us about how these things work. Looking at the one on the right, these numbers here, okay, those numbers though, there, if you remember, that's actually my initial point, or the point where we got that from, so that would be, I plus 5j, minus k. That would be that first point. Okay, our initial point P0. And these other values here, the values that are in front of T here, they tell us the direction, if you remember this from the previous video. So that'll be V is equal to 1I minus 2J plus 3K. So or what we can already figure out is the direction of the second line is equal to I minus 2J plus 3K. Done. It's already written down there. You can just read that off straight from the parametric equation. The one on the left, we need to do a little bit more work to get that. What we need to do is write that as parametric, and then we can go from there. Okay, so if we set that equal to t, all of those, then we have x is equal to 2t minus 1, y is equal to negative t plus 2, and z is equal to negative 2t minus 3. So that's just rearranging for x, y, and z along the way. And again, we can pull out our direction vector from those values in front of the t's there, okay? So that's what we're going to get. And so that tells us that my first velocity vector is equal to 2i minus j minus 2k. Okay, so there's my V1 and my V2. Now I can jump to my formula from above, where theta is equal to arc cos. And it's going to be the magnitude of V1, V2. So let's do V1, V2 now. Okay, so 2 times 1 is 2. Negative 1 times negative 2 is also 2. And negative 2 times positive 3 is negative 6. And its magnitude, so I'll put both those two things there. A bit wobbly with my vinculum there. Okay, and so then the magnitude of V1 is going to be 4 plus 1 plus 4, so that's going to be root 9. Still wobbly. And then my second one is going to be 1 plus 4 plus 9. So that's 5 plus 9. So that's 14. So I'll just simplify that before I go and put it into the calculator. 2 plus 6 is 4. 2 plus 2 is 4. 4 take away 6 is negative 2. Because it's modulus, it's going to become positive. And so I'll just leave that because I'm just going to put it straight into the calculator like that. Speaking of which, I'm just going to write that down quickly before I go to that so that I remember what to put in my calculator because I'm changing screens. So let's go now to the CAS. Oh, I haven't booted up yet, so we'll have to wait a second. My apologies. And just a few tips. Make sure that when you're doing sort of angle sort of stuff, that you know whether you're in radians or degrees. So I like keeping my calculator in radians at all times. And I'll show you a couple of things as we go. So what we want is we want to go to arc cos. I want a fraction. And on the top line, it was just 2. On the bottom line, it was root, well, it was root 9, wasn't it? So I'll do root 14. Oh, what happened then? I don't know. Something weird happened there. It was root 9, which is 3, and then root 14. If I push enter now, it's going to give me this exact sort of thing here. So if I press control equals, that'll give me the approximate. But again, that's in radians. And so we need to convert that to degrees. One way you can do it is to press the radians button up here and then to press that control equals again. It will give me my angle of 79.7 degrees. The other way to do it and not come out of degrees, because I find that sometimes when you come out of radians and change to degrees, you might forget that you're in degrees and some other stuff might happen. So the other way to do it is if you've typed this in and you push enter and it gives you that, you can also create it, force it to go. So you click on the book, you search for DD, and so you can actually type D to find this section, and you come down to DD. If you push enter there, and then enter there, and then control equals, that'll also change that into decimals, into degrees for you without coming out of radians. So that just converts it for you. But that's my answer anyway, which is, let's call it 79.7 degrees, depending on the question that you had. And depending on how many, so 79.7 degrees. Don't know why the degrees is not working there, but anyway. And so that is my answer there, 79.7 degrees. I know it's not typing. Thank you.